Hello and welcome back to the BHS channel, the Biochemistry for Health Sciences channel. And today we'll talk about glycogen. So first of all, it's important to note that glycogen, serum glycogen or blood glycogen is not something we measure in the clinical lab. So it's not in the chemistry lab panel. Okay, so it's not a test that we do. So glycogen is how we store glucose. So since glucose is so important for survival, blood glucose concentration, so therefore glycogen is very critical for maintaining our blood glucose, and we'll talk about that in a few seconds. So glycogen is found in most cells, but the most of your glycogen in the body is found in muscles, since muscles do need a lot of energy, and liver. You can see liver has a lot of glycogen. Okay, and liver is the organ that maintains the blood glucose, make sure there is enough blood glucose during starvation periods when we are sleeping at night, or when we haven't eaten for more than one day, so on. Okay, brain has a little bit of glycogen too, but nothing very small compared to, say, the liver or the skeletal muscle. So what is so special about glycogen, SAR? SAR simply means structure, A is activity, R is relationship. That means what is in the structure of glycogen, what is so special about glycogen structure that enables it to carry out its activity, whatever its biological activity is. And so when you look at that, you can see that glycogen is glucose joined together, okay, all mostly here by what we call alpha-1,4, a lot of alpha-1,4, and then once in a while there's a branching, which is alpha-1,6, this branching. Okay, so glycogen is a molecule that is extensively branched, a lot of branches after branches. Okay, dendritic, highly dendritic, just like tree branches, very, very branched structure. So the question is, why is glycogen has so much of branches? Why is it so extensively branched? And so once again, remember that glycogen is how we store glucose. So when we break down glycogen, we get glucose, and this glycogen in the liver is the one that this glucose will enter your blood vessel, and this will maintain your blood glucose, make sure it's greater than about 40 or 50 milligrams per deciliter. Because if that doesn't happen, then your brain and your red blood cells, these are the two systems that will really, really suffer. Okay, the brain doesn't get enough glucose, you can get into a coma. So we want to make sure that when we release glucose during starvation, when we break down glucose, this happens fast enough that it can always maintain the blood glucose. And by having branches, you see, by having so many branches, one of the enzyme molecules can sit on this branch, and all these branches end in non-reducing ends. So these enzyme molecules recognize the non-reducing ends and come and sit on the branches and start breaking down glucose. Okay, so instead of one enzyme working on glycogen, there are many, many enzymes working on the glycogen branches, breaking glycogen down to glucose, and then that glucose is exported out by the liver cells to maintain your blood glucose. Okay, so very quick degradation of glycogen or catabolism of glycogen to give you glucose, which then can enter the bloodstream and maintain blood glucose levels. Same thing happens during after a meal. All the glycogen that we used up during when we were sleeping during early starvation, now we have to replenish the glycogen. So similarly, when the glucose comes from your diet, so here's diet glucose, it goes to the liver, and this glucose can quickly be made into glycogen so that we can replenish our glycogen stores so that we are ready for the night's sleep when we get into starvation. So this architecture, this branch architecture, really helps increase the rate of synthesis and degradation of glycogen. In previous videos, we talked about osmolality. We want to make sure that the osmolarity of compartments are held at a certain level. Otherwise, water can get in or get out. Okay, so the nice thing about making this large polymer, glycogen is a very huge polymer, very large molecule, is that as far as osmolarity is concerned, this is just one particle. Okay, so by storing glycogen, you are not changing the osmolarity of the cytoplasm, of the cell cytoplasm, and therefore you're not going to mess around with the, that's not going to cause water. Instead of storing glycogen, if you store thousands of glucose, those thousands of glucose is going to increase the osmolarity. Okay, it's going to increase the osmolarity. If that happens, then water is going to enter the cells. Your liver is going to become, your liver cells are going to become swollen, and that's dangerous. Okay, so by storing in large particles, because osmolarity doesn't care about the size of particles, it just looks at the number of particles. Okay, so that's another useful feature of the branch structure of this molecule, glycogen. So as I mentioned, the liver glycogen basically maintains, and we'll talk about this under metabolism, different physiological states of metabolism after a meal, what happens after a meal, what happens when you're sleeping during early starvation, and what happens if you don't eat for more than one day. We'll talk about this in future videos. But basically, for now, just to remember that your liver glycogen, is enough glycogen to maintain your blood glucose for roughly 24 hours. Okay, roughly 24 hours. So the question is, if glucose is so essential for survival, so essential for your brain, why don't we just store more glycogen? Why don't we store in the liver cells, just store more glycogen? And one of the problems of glycogen is because glycogen has so many OH groups, just like glucose, when you store glycogen, you attract a lot of water. Okay, because that's what makes glycogen soluble. The water gets attracted to it. So every gram of glycogen you store, there's about 3 grams of water associated with it. So trying to store glucose instead of glycogen and trying to store too much glycogen is going to need a lot of water. Okay, so that's why we just don't store long-term storage more than 24 hours as glycogen. We use lipids because lipids don't attract water. Okay, so that's the reason why we do not store more glycogen in the liver than what is needed for one day, because we're hoping that within one day you can find a way to get out of your early starvation and survive. Okay, that's a quick overview of glycogen. We will talk about glucose in the next video. Until then, goodbye, and hopefully we'll see you in the next video.